Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at finding the nth term of a GP, which means geometric progression, or a geometric sequence. So GPs look like this. So they start with a first term that I'll call A, or T1, doesn't matter. And then the next term will be A times some common ratio. Then the third term, I'll take the previous term and multiply by the common ratio again, and so on. This is what all GPs look like and can be written as. So I'm sure you can see a pattern here. First term's A, second term is AR to the power of 1, third term AR to the power of 2, so the nth term will be AR to the power of n minus 1. And this is the formula to find the nth term of a GP. So that's the formula we'll use throughout this video. So to use it, you need to know A, the first term, R, the common ratio, and N is obviously the number of the term you're interested in. So let's have a go at these questions here. Firstly, what is the 10th term of the sequence 3, 12, 48, 192? So this is a geometric sequence. The common ratio is 4 because I'm timesing each term by 4 to get the next term. So clearly A is 3. So we have here A equals 3, R equals 4. Now, if I'm interested in the 10th term, N is 10, the number of the term I'm interested in. So using the formula above, T10, term 10 is just going to be A times R to the power of N minus 1. Just remember, order of operations, you do the power here first. So putting that into my calculator, I get 786,432. Yes, I get a very big number. This should be reminiscent of when we did exponentials. It's increasing exponential, so it gets big really, really fast. And that's my answer. So let's have a go at this one here. So this is another geometric sequence. Of course, A is minus 1024. So each time, to get to the next term, I'm timesing by negative 1/4. So 256 divide negative 1024 is negative 1/4. Minus 64 over 256, negative 1/4. The common ratio is negative 1/4. So this time I want T22, so I want N to be 22. It's just going to be A times negative 1/4, which is R. So whenever you're substituting a negative, put it in brackets, and then I'm going to raise that to the power of N minus 1. So, putting that on our calculator, we get a very, very small number. So this is getting very small quickly. It's another example of an exponential. It's a negative exponential. So we get 1 over 429,496,7296. So a very small number, and you could write this as a decimal yourself. So this would be 1 over 4,294,967,296. All right, let's look at some more complex questions. So let's do this question. Whereas which term of the sequence 5, 10, 20, 40, etc. is equal to 40,960? So let's use our formula Tn equals AR to the power of N minus 1. So if I want to know which term, I am finding N. So let's substitute in the things we do know. So whichever value of N it is, the value of that term Tn is 40,960. So I'm changing Tn to 40,960. So we know A is 5, and we can work out quickly R is 2. I'm timesing by 2 each time. So this is the equation I have to solve. So you know how to solve exponential equations. We've done it before. So we're going to start by dividing each side by 5. And then we get this equation here. So we've gone through a few methods of doing this. You could use trial and error, graphical methods. Easiest way is to take the log of both sides. So if I take the log of 8,192, that will equal the log of 2 to the power of N minus 1. So now we can divide each side. So log 8192 divided by log 2, that will give me N minus 1. Now, if you put this in your calculator, you should get the value 13. So 13 equals n minus 1, add 1 to both sides, and you get n is 14. That means the 14th term of this sequence is equal to 40,960. All right, let's now do one more question where you're not actually told A or R specifically. So let's have a look at this one. What is the 15th term of the geometric sequence in which the 6th term is 486 and the 11th term is 118,098? So the thing is, we know that T15 is equal to A times R to the power of n minus 1. The problem is here, we're not told A and we're not told R. So we have to do a bit of work to find out what A and R are. But we can use the nth term of a GP formula to find A and R. See, I know for any GP, T6 is equal to AR to the power of 5, and T11 is equal to AR to the power of 10. So in this case, I'm told T6 is equal to 486, and T11, 118,098. So what I have here are sort of two kind of simultaneous equations, but I'm not going to solve them simultaneously as I normally would. All I need to do is divide this equation by this equation. Now, hopefully this rings some bells. We did this in exponential modeling. Remember, that was where you had equations of the form y equals a times b to the power of x. We divided the larger equation by the smaller one to find out what b was. So we're going to do the same sort of thing here. If we divide this equation by this equation, the a's will cancel out and we'll be left with just one variable r. So we go a divided by a, of course that's just 1. R to the power of 10 divide r to the power of 5 using our index laws is just r to the power of 5. You keep the same base and subtract the powers. Now 118,098 divided by 486 gives us 243. So r to the power of 5 is 243. So r is going to be the 5th root of 243, which you can just put straight on your calculator. In this case, it's 3. Now I need to issue a word of caution when you're having an equation like this. See, if the power is odd, as it was here, there's only one solution. But if I get a situation where there is an even power, there would be two possibilities for the common ratio. They'd both be the same number, but one's positive and one's negative. So I just wanted to show you, if you got something like r to the power of 4 is 16, r could be 2 or negative 2. So those two possibilities, that ambiguity arises only when the power is even. When you're doing questions like this, where you're dividing to find r. So just be aware of that. Even power, there's two possibilities for the common ratio. Odd power, as we had here, there's only one possibility for the common ratio. So we know the common ratio is r, just like we would in simultaneous equations, just like we did in exponential modeling. We're going to substitute r equals 3 into either equation, doesn't matter, to find what a is. So I have a times r to the power of 5 is equal to 486. Divide each side by 3 to the power of 5. A is 2. So that means, of course, the first term here is 2. Now we have a and r. We have all we need to find T15. So it is going to be a times r to the power of 14. That will be the value of the 14th term. And putting that on our calculator, we get 9,565,938, and we're done. All right, sorry about the long video, but thanks so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.